Okay.
So then this becomes stroke times the revolutions per minute divided by 6. And that's your piston speed. So let's pretend for a second we want to use this to calculate the average or mean piston speed of what might a stroke length be for an engine. You use what we did yesterday? Alright, so this will be 3.48 inches. And what about revolutions per minute?
Hey guys, let's do a pretty common engine. Since y'all like racing, we'll do something that's Daytona restrictor plate, 7,200 RPMs. Okay, that's average. 72, 7,200.
All right, RPM. And we're going to divide by 6. So what's the mean piston speed for this engine? You're going to need a calculator or something.
Yep, pull it out.
You can't do this on your fingers.
Oh gosh, thank God it's messed up.
4,176.
Oh boy.
Anybody want to confirm
Yeah,
that?
that's right.
4,176.
Yeah.
Beats per minute.
And that's beats per minute. Okay.
Let's move it on with it.
Oh, that's.
And that may mean something to some of you because you're used to talking about feet per minute. But what if we wanted to change this into miles per hour? Just to get a kind of a better idea of what's going on. So if this is, I'm going to come over here with it. If this is 4,176 feet per every 1 minute, I want to change this to miles per hour. So we need to know a couple things.
Feet to the mile, something like that.
Yeah, we need to know how many feet are in a mile. 5,280 sounds good. So I'm going to multiply by, there are, in 1 mile, there are 5,280 feet. Now notice the way I set this up, because 1 mile and 5,280 feet are equal. So what's a number divided by itself always? No, try again. It's 1, right? A number, any number divided by itself is 1. So what did I actually multiply by? 1. Okay. Now if you guys do really well today, I'm going to talk to Mr. Shirley. I'm going to see if he'll multiply all your averages by 1. Okay. So if you guys pay attention and do that, I'll talk to him.
Oh, he about got
Are you happy about that? Now if you're bad, I'm going to tell him to divide it by 1. Because it doesn't matter, right? Multiplying by 1 doesn't change the value, but in this case, it changes what it looks like. It changes the units that it's in. So when we're talking about feet, I put feet on the bottom because I wanted to eliminate the unit feet. You guys have done this in 9th grade. And then I've got miles per minute, but I want miles per hour. So I really need to change this into hours. So what should I multiply by to change this to hours? Because there's 60 minutes in an hour. So then, yeah, I'm going to do, kind of run out of room here.
Clear out some more over here. We're good. We know fine.
And then this is going to be, right, you said 60 minutes in 1 hour. So then again, minutes are gone. And then we just start multiplying across the top. So 4,176 times 60 over 5,280. Again, here's where a calculator helps.
Give them some extras, guys.
So 4,176 times 60.
47,45.
The whole thing? Well, what was 4,176 times 60?
250,500.
250,000 what?
560.
And then when you divide those out, apparently you get this, you want to confirm that?
Divide by,
Okay, so then this is in 47.45 miles per hour.
This one is 9.025. Deck house is what it's called. Okay, so that's the amount of room you got to work with. You have no more room than that, no matter what you build.
And the question I had when I was working this out was, so why is this important to know for my engine? I mean, as long as I put the key in and turn it, and it turns on, I'm okay, right? That's kind of what I was thinking. Why do I need to know if I'm working on an engine or building it? Why do I need to know piston speed? So that's where Mr. Shirley comes in,
Okay,
because I don't know.
all right, I'm gonna show you this right quick. Hopefully y'all can see it. Righty?
well done.
This is in slow motion.
You want to flip this?
You can. Okay, here we go.
Miss Barrett, you have a visitor at the front office.
Watch what's happening. That's in slow motion. Everybody got it?
Yeah.
Right, I'm gonna stop it. Okay. All right, why this is important. We're moving 8 pistons at this speed. And just 9 inches. It's got 9 inches of travel, and it's moving this fast. It's called flame travel. What I've talked about all this time is we know that if we know our piston speed, we know our RPM, then we can kind of figure out flame travel. But flame travel, guys, what happens here, if this piston speed gets much more than 52, 53 RPMs, just by knowledge of knowing, okay? Okay, so this will be another formula, and we'll show it, but first off, before we can do that formula, we got a lot more compression ratios and stuff we got to do before we go to that formula. But the reason we want to know piston speed is because we have to put the pistons in now. So we should pretty well know our application, what we're doing. But if we get much faster than 52, what's going to happen is our piston is actually going to outrun the flame. Because y'all seen these ports open up right here that allow fuel and air to come in and exhaust to go out. Well, what's going to happen is we're actually going to be dumping fuel and air in on ratios running roughly, probably about 70% fuel, 30% air, and pushing this, and it's going to come out the exhaust. So what's going to happen is, about the time this thing blows, you know, one cylinder blows, as the other side pushes down, you can see that from over here. This one's coming up, that one comes up, this one goes down. So one goes boom, okay? If one goes boom, then it blows the other one up. So when this ignites, as it ignites and blows back down, it's blowing the other one up. So we have to have to be efficient. To be efficient, what we got to do is make sure we're not outrunning the flame travel. Our piston's already started down, and the boom has kind of took place, but it's not, and the piston's too far down, already down. So we're actually losing the effect of the boom in the cylinder, okay?